and welcome back to Introduction to Geology. My name is Paul Eric, and I teach physics, astronomy, and geology at Ozarks Technical Community College in Springfield, Missouri. This lesson is going to be a Unit 4 review for your Unit 4 exam. And it's going to cover the following lessons. So lesson number 14 on rivers, lesson 15 on oceans, lesson 16 on groundwater and caves, lesson 17 on deserts, lesson 18 on glaciers, lesson 12 on mineral resources, lesson 19 on environmental geology, lesson 20 on planetary geology, and then finally lesson 21 on the geology of Missouri. Now you'll notice that some of these lessons have an asterisk. So that meant that they were optional lessons, and so what you need to do is check with your particular instructor to find out whether those lessons are going to be on the Unit 4 exam. So I'm going to cover all of these lessons and review them, but you want to find out if there's any of these lessons you don't really need to worry about. Okay, so we're going to first begin by talking about lesson number 14 on rivers. So this is streams and floods, the geology of running water. Okay, now you always want to read the lesson objectives. So this gives you a good idea for what would be on the exam if this material was on the exam. Okay, and then this corresponds to chapter 14 out of your textbook. And then there were 2 Earth Revealed episodes that you might want to watch that deals with rivers. Okay, first thing you've got to know is, how do rivers form? So you should be familiar with the words sheet flow, and then rills, and then streams, and then you should know which one comes first, and which one comes second, and then which one comes third. Okay, then you should know what a watershed is, and that you should know what a divide is. So a watershed is going to be an area that is going to be drained by a river, and then watersheds are divided by a divide. Okay, you should know the definition of the slope of a river, which is also the gradient of the river, and you should be able to calculate mathematically the slope of a river. So it's going to be elevation, so it's going to be this distance divided by the horizontal distance, which is going to be this distance here. And so it's exactly like the definition of slope that you know from geometry. Okay, then you should know what discharge is. So discharge, another name for it is the volume flow rate. It's given by the letter Q, but you don't need to know that. And it's the volume of water that flows in a river per second. And then volume is going to be in cubic meters per second. And another way of calculating the discharge rate is by knowing the velocity of the river, and then by also knowing the cross-sectional area of the river. And so down below there, it shows you how to calculate the discharge, and it does it for 2 particular rivers. So you should be able to do that on the exam. If you're given the speed of the river and you're given the cross-sectional area of the river, then you just multiply those 2 numbers together, and then that's going to be the discharge, the amount of water per second that is flowing through the river. Okay, and then another thing you should know is the velocity of a river. Okay, now you're not going to need to know this formula for the exam. If you do, I would give you that formula. So I would put that on the exam. But that's V for the speed of the river is going to be equal to the square root, and then S is the slope of the ground, which you now know what slope is. A is going to be the cross-sectional area of the river. R is going to be the roughness of the bottom of the river channel, and then P is the wetted perimeter. And so all of those are defined there. And so I could give you a question like, if the slope increases on a river, what's going to happen to the speed of the river? Well, it's going to increase, and you can see that from the formula because S is on the top part of that fraction. So if S increases, V has to increase. Also, if A increases, the area increases, V has to increase. But notice if the roughness increases, the R is in the bottom part of the formula, which means if R gets big, V gets small, which is what you expect. So if the water is flowing over a rough surface, it's going to slow down. And then the same thing for the wetted perimeter. If that's larger, then the speed is going to be smaller. Okay, then you should know what load is. So you need to know what do we mean by the dissolved load, and be able to give me examples of things that might be dissolved in water. What is the suspended load, and then what is the bed load. Then there's some other words here. So the capacity is the maximum amount of load that the river can carry, and then the competence, though, is the maximum size of the load. So is it sand, teeny tiny particles, or is it rocks about this big? So that's the size of the load. All right, let's take a break, and when we come back, we will continue our Unit 4 review.